it's me, Priska Joseph. So dear children, we are starting our revision classes, that is Revision 2025. You are doing well, you are practicing well, you are studying well. Don't worry about your result. Now only on focus your studies, okay? Your result will be good one, okay? So let's start. So the first chapter is chapter 1, real numbers. Okay. So in this series we are discussing all the contents in capsule form, and after that we will discuss the important questions, most frequently asked questions, POIQs, etc. Okay. So get ready. Before entering into the session, if you are watching my channel, please subscribe it. Be a proud member of Ravnats family. Okay. And don't forget to hit the bell icon for the notifications. And your comments, that is the fuel for my journey. So please comment below. So let's start discussing some numbers. First one is natural numbers. What is natural numbers? It is counting numbers. So we start counting with 1, 2, 3, etc. So these are natural numbers. If is adding with these natural numbers, then it is said to be all numbers. Okay. What is integers? All positive numbers, negative numbers, including 0 is said to be integers. Okay. Then what is real numbers? What is real numbers? All fraction numbers, negative numbers, positive numbers, 0, excepting imaginary numbers. Okay. Is said to be real numbers. Then finally, what is rational numbers? Rational numbers. Any number which can be represented in the form of P by Q. Okay. Represented by P by Q, and where Q not equal to 0 is said to be rational number. So these are some basic concept of numbers, and let's move on to theorem 1. That is, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. Once again, every composite number can be expressed as a product of primes. That is, each and every composite number can be represented by the product of prime numbers. Okay, and this factorization is unique. Okay, this factorization is always unique apart from the order in which the prime factors occurs. No matter which is the order of the prime numbers. Okay, so this is theorem 1, and there is an example, that is 32,760. Okay, 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. Because of lack of time, I am not explaining the factorization. Okay, only factors we will discuss. Okay, so it is 2 to the power 3 into 3 to the power 2 into 5 into 7 into 13. No matter, we can write the prime factors no matter the order. Okay. So this is the theorem, and next one is LCM into HCF. That is, product of LCM into HCF is equal to product of two numbers. Let A and B are two numbers, and the product of these numbers is equal to product of their LCM and HCF. Okay. And now there is an explanation for HCF and LCM. That is, first one is HCF, that is product of smallest power of each common prime factor in the numbers. What is HCF? Product of smallest power of each common prime factors in the numbers. What is it? Let me explain by taking two numbers, that is 6 and 20. What is the factors of 6? That is 2 into 3. What about 20? 20 can be represented by 2 times 5 times 2 times 2 times 5 times 2. That is 2 to the power 2 into 5. Okay. So what is HCF? Here I am writing here. That is, HCF is equal to product of smallest power of each common prime factors. Product of smallest power. Here it is 2 to the power 1, and in the case of 20 it should be 2 to the power 2, which means product of smallest power. What is the smallest power? 2 to the power 1. Okay, the product of smallest power of each common prime factors. Here 2 is the common prime. 2 is the common prime factors in between the two numbers 6 and 20, and we consider the smallest power. Okay, so here the smallest power is 2 to the power 1, that is HCF is 2. Okay, this is the easiest method for finding HCF and LCM of two numbers. Okay, so next one is LCM. What is LCM? Product of greatest power of each prime factor involved in the numbers. Product of greatest power of each prime factor involved in the numbers. Okay, so between these two numbers, the greatest powers of factors are 2 to the power 2, 5 to the power 1 into 3. Okay, so on multiplication these numbers we get LCM. Okay, so a very important part of this chapter. Okay, let's move on to the next session. Finally, theorem 2, that is, let P be a prime number if P divides A square, then P divides A where A is a positive integer. Okay, once again, let P be a prime number if P divides A square, then P divides A where A is a positive integer. Okay, panic, we will discuss it in the problem session. Okay, so these are the important points from the chapter 1 real numbers. Okay, all these are theoretical concepts, and next we are doing some important questions from this chapter. Okay, children, let's start our important question from this chapter. So the first one is, express each number as a product of its prime factors. Okay, express each number as a product of its prime factors, and there are three examples are given: 3825, 7429, and last is 156. So let's do it together. So the first one is 3825. Since the ones place is 5, we have to divide this number with 5. So 7 5s are 35, 3 is the 6 5s are 30, and again 2 is the 5 5s are 25. Again 5, 1 5 is 5, 26 is the 5 5s are 25, remaining 5 is the 153. Okay, so it is clear that this number can be divided with 3. Okay, so 5 times 3 is 15 and 1 3 is 3. Okay, so 51, again 3, 1 3 is 3, again 21, 17 is the, okay, 7 3 is 21 and 17. So the numbers can be, so the factors can be written as 5 to the power 2 times 3 to the power 2 into 70. Okay, so this is the factors of the number 3825. Okay, see, all these numbers are primes. Okay, so this is the answer. Let's move on to the second one, that is 7429. Okay, this is 7429. Okay, so we can't divide this number with the prime numbers like 3, 2, 7, etc. So we have to take 70. Okay, so 7429 upon 70. What is it? 7429 divided by 70. Okay, 17 times 4. What is 17 times 4? 7 4s are 28. Remaining 2 is there. 1 4 is 4. 4 plus 2 6 68. Here 62 is there. Right? Yeah, 62. And 17 times 3 is 51 is there. Then finally 1 is there. 119. And 17 times 7. What is 17 times 7? 7 times 7 is 49. 4 is there. 1 7 is 7 plus 4 is 11. That is 11. 119. Okay. So 437. 437. That is 437. Okay. Okay. Then we can't divide this number with the prime numbers 2, 3, 7, etc. So we can't divide this number with 70. So we have to take another prime number which is 90. Okay. So 19 is the 219 is 38. So here it is 57 and 19 into 3. What is it? 19 into 3 is 57. Okay. So 57 and remainder is 0. So 23. Okay, 19 and 23. Yeah, 23 is a prime number. Okay, so we can't divide this number with any other number. So the factors are 17 times 19 times 23. Okay, so factors of 7429 is 17 times 19 times 23. Okay, hope it is clear for you. And let's move on to the third one, that is 156. Okay, so 156, that is, we can divide. So we can divide it easily by taking 2. It is 7 times 2 is 14. 16 is the 8 times 2 is 16. Again with 2 we get 3 times 2 6. 6 remaining 1 is the 18. 9 times 2 is 18. And finally 3. 1 3 is 3. 1 3 is 3 and 3 times 3 is 9. Okay. So 13 is also a prime number and the factors are 2 times 2 times 3 times 13, that is 2 square power 2 into 3 into 13. So this is the factors of 156. Just children, hope it is clear for you. Please check the playlist of the chapter 1 real numbers in my channel. Okay. So let's move on to the next question. Now the second question is, given that HCF of 306, 657 is equal to 9, find LCM of these two numbers. Okay, so this is the question and we know that there is an equation connecting HCF, LCM and the two numbers is product of HCF and LCM. Okay, that is HCF into LCM is equal to product of the numbers, that is A into B. A and B are two numbers. Okay, by using this relation we have to find out the value of LCM, that is HCF is 9 into LCM, which we have to find out, is equal to A into B. A is 306 into B is 657. Okay, so what is LCM? LCM is equal to 306 into 657 divided by 9. Okay, is it clear? Now, this 9 can be completely divisible in 306. What will be the answer? That is 3 times 9 is 27 and 3 is there, that is 36, that is 34 is there. 4 times 9 is 36. So, 34 into 657. What is it? That is 657 into 34. Okay, 7 times 4 is 28, 2 is there, 5 times 4 is 20, 20 plus 2, 22, 2 is there, 6 times 4 is 20, 6 times 4 is 24, 24 plus 2 is 26, 7 times 3 is 21, 2 is there, 5 times 3, 15 plus 2, 17, 6 times 3 is 6 times 3 is 18, 18 plus 1, 19. So 8, 3, 6 plus 7, 3, 9 plus 3, 12, 1, 1 plus 2. Answer is 22,338. 22338. Okay, so this is the LCM of these two numbers. Okay, it is a very important equation. Try to study this. Okay, so that's it.